All right, today we're going to be doing linear and quadratic systems by graphing and by substitution. So we have done systems before. We did systems of linear equations. Do you remember when we did substitution and elimination, all that good stuff?
Yes.
Nod your head, yes. All right, this is very similar, but we have a quadratic and a linear. All right, so that's how it's differing. Because you have a quadratic and a linear, then in the calculator, when y'all try to do linsolve like this, y'all remember this?
Yes.
Okay, this is not going to work because this is a system of linear equations. We have a quadratic. So this does not work because you have a quadratic. Does that make sense? All right. But if you have a calculator, it is still super easy because you can just go ahead and graph it. Clear my graph out. All right, so we're going to go to the graph. We're going to type the first one, negative x squared minus x plus 6. Hit enter. And you get a quadratic. Anybody need help plugging in that one?
Yes.
All right, to get the other one, you're going to press tab, and that will bring up the other equation where you can type in x plus 3, your linear.
Oh, it's linear.
Yay!
Why are you so bored?
I guess we have to find the point where they meet.
Very good. Yes, points where they intersect is what you're trying to find. All right. So we are no longer looking for zeros. That is super important. When you have a system, you are finding points of intersection.
So we press forward.
Yeah, so menu. So if you want to write the steps down on your notes so you have them, menu, analyze your graph. So down here at 6, analyze, and intersection. Yep, and then you're going to highlight. So we're going to press our button, we're going to highlight. Now how many times do they intersect each other? Twice. So we are going to have to repeat. Alright, so do my steps again. Menu, analyze your graph, intersection, highlight the other one, and the other one is at 1, 4. I do want you to draw your graphs so you get used to the idea of them intersecting on the graph. That is the point you're finding.
What's the other one?
1, 4. So negative 3, 0, and 1, 4. Your graphs don't have to be perfect, but draw your intersection dots in the correct spots. So if you were to look back on these notes,
Is that all it is too?
that is all the front is. Yeah. Yes. If you have a calculator, it's super, super easy. Graph it, find the intersection points. That's all you got to do. So calculator, it's pretty simple. All right, for number 2, if you want to ignore me and try to do it yourself, that's fine. To clear your calculator, doc B will clear it. You can go back to the calculator. And I'm going to type in the quadratic, x squared minus 2x plus 1. Hit enter. Press tab. Type in the other one, 2x plus 1. Hit enter. Alright, so on this one, this point right here is pretty obvious. Where it intersects, we can find this one. So we do know that this point here is at 0, 1. But if you look up top here, it looks like it's gonna intersect, but it's not showing up on the calculator. So you have to zoom your graph out. So menu, window zoom, zoom out, and then you get this little guy here. Just press it once, see if that helps. If you have to zoom out more, keep pressing it. But just one time is enough for me to see the intersection point here, and so now I can do menu, analyze graph, intersection, and boom, highlight. And so it intersects again at 4, 9. All right, any questions about calculator, graphing, that good stuff? We good?
No.
Sweet.
Why does the practice take so damn long?
No, the practice won't take long.
How many questions?
The practice you have 4 graphing and 4 like these. Okay, so on the back, now we're going to be solving these systems algebraically by substitution.
Oh my god.
So we are assuming we don't have a calculator now, which is why we need to know how to substitute. So no longer have a calculator. Now, when you have linear systems, all right, before, like way back when we talked about linear systems, we did substitution and we also did elimination. You remember? Okay, you cannot eliminate because of the x squared. So you only can do substitution. So substitution is the only thing we can do.
What if you have two?
It gets all funky because you have the 2 answers, and so it gets weird.
No, I mean like what if you have two?
Quadratics?
Yes.
Yeah, it's still substitution. Alrighty. So, first step is going to be to substitute one equation into the other one. So you can take your 3x plus 2, and since it equals y, we can sub it into the y of the other equation.
What?
In other words, set your 2 equations equal to each other.
So y equals y.
No, because y equals y. So we're going to set our 2 equations equal to each other.
3x plus 2 equals x squared plus x minus 6.
Yeah.
She is such a
Okay, but couldn't that work the other way?
You could put the x squared plus x minus 6 first. Like x squared plus x minus 6 equals 3x plus 2. You could put it either way. Alright, so I set my 2 equations equal to each other. Second step, we are going to move everything to one side. We want to keep x squared positive. Alright, so whatever keeps the x squared positive, that's the way you're going to go. So I'm going to move the 3x by minusing it, and I'm going to move the 2 by minusing it. Alright, so are we still good? Any confusion?
Wait. So, everything to one side. So it'll eventually equal to 0?
Mm-hmm. Yep. Yeah, so we're equaling to 0. So all of that goes away. That equals 0. Over here, x squared. What is x minus 3x?
Oh, no. Negative 2.
Minus 2x. And what is negative 6 minus 2? Minus 8. So you should have everything equaling 0 now. Alright, the third step is going to be to solve for x. And if I were you, I would try to factor. Now, keep in mind all the ways that we have solved quadratics without a calculator. Okay, so you could complete the square. You could do quadratic formula, but factoring is going to be the fastest and the easiest once you get good at it.
Oh, it's 2x.
All right. If it is unfactorable, then yes, you would have to do quadratic formula or completing the square. All right, but I think all the ones on your practice are either factorable or they have a GCF, and then these both are factorable. Yes, so we're going to do the x thing. So we want what multiplies to give me negative 8 but adds to give me negative 2.
Negative 2, 4.
Negative 2, wait, no, positive 2 and negative 4.
Making snow.
You're right.
Right, positive 2 and negative 4. So we're going to put those in my factors. X minus 4, x plus 2. Okay, and then what do you do after you factor? Set them equal to 0. So we're going to do x minus 4 equals 0. X plus 2 equals 0.
How'd you get minus 4?
Because you want them to make a negative 2.
Oh my god, I said negative 4.
X equals positive 4.
Alright, good. So, shh, stay with me. I'm not done yet. X equals 4. X equals negative 2. We're not done.
Oh no.
Not done. Or close, but we're not done. Because I'll flip it back over. But what are your answers? What should they look like? Coordinate points. What are you missing?
Why?
A y value.
No.
So you got to plug that in to find out?
Yep.
Wait,
Yes, so yes, we have to plug in to find y. Yes, we're going to plug in both x's. And we are going to pick which one is going to be... Which one is going to be easier? The bottom one. If I were you, I would plug it into the linear one because that one is going to be a lot easier. You don't have exponents.
Y equals 12. Y.
All right, so my linear equation is 3x plus 2. For the first point, what x value am I plugging in? 4. So what's 3 times 4?
12.
Plus 2? Very good. Okay, for the other y value, what x am I plugging in? Negative 2. And what is 3 times negative 2? Negative 6 plus 2? Negative 4. All right, still not done.
Now you gotta
What do you mean you're not done? It would be negative 2 for negative 4.
wait,
and
no,
it'd be
never
4.
mind.
Yes, I want them as coordinate points. So that's the very last step.
I just did that. I
So
just
we
said
got to
that.
put
I said
4
it's 4, 14, and negative 2.
and negative 2 and negative 4.
Yeah. And then you're done. So write them as coordinate points so I know what x goes with what y and what y, goes with what x or whatever.
Okay, are we done now?
Now we're done.
Can I get the practice?
No, we're going to do number 4 as a class, and then you can add the practice.
You said we were done.
But isn't it the same?
Oh, we're done with this problem. What?
Isn't it the same thing?
Yeah?
Can I get the practice since I already did it?
Ooh, she already. Then what's the answer?
Pretty sure that's right. I don't know. I kind of forgot what the answer was.
Oh my god.
Yeah, what
that's
is
wrong.
Wait.
Not everybody's brain works.
Yeah, no, that's right.
Wow.
Alright, guys, let's shut off the recording.